soon we can see the entire planet, our home in space.
This experiment took place in the Southern Ocean off the coast of Antarctica. Antarctica is surrounded by the Arctic Circumpolar Current. This current is the strongest in the world and flows clockwise around the continent. The Arctic Polar Front Zone is an area where the polar and tropical air masses mix and transition. Eddies are a normal occurrence here. An ocean eddy happens when current instabilities lead to the swirling of fluids. The size of the eddy can be from 10 to 500 kilometers in diameter. It can remain present for days or months at a time. This experiment focuses on proving the iron hypothesis. Glaciers in the Southern Ocean contain iron. The Arctic polar front causes iron dust from the glaciers to mix with ocean water. This iron will cause a significant increase of algae growth. The algae is formed by a type of phytoplankton called diatoms. Diatoms are found on ocean surfaces and use carbon to make chemical energy. The diatoms take carbon dioxide from the atmosphere. They are amongst the leading groups of plants to remove carbon from the air. During photosynthesis, the algae will get heavy with carbon dioxide, die, and sink from the surface to deep ocean and the ocean floor, where it will sequester or hold significant amounts of carbon from the atmosphere. The European Iron Fertilization Experiment team used an eddy 60 kilometers in diameter to test the hypothesis in. An eddy was a great choice because it creates a natural ocean barrier between the experimental and the control group. The iron was introduced into the eddy to create a phytoplankton bloom. The team recorded the amounts of chlorophyll represented by CHL, particulate organic carbon represented by POC, particulate organic nitrogen represented by PON, particulate organic phosphorus represented by POP, and they monitored the amount of dissolved nutrients in the water represented by the three dots gathered together. The amounts of the elements were measured at different ocean depths. The results show there was a linear increase in the amount of chlorophyll, particulate organic phosphorus, particulate organic nitrogen, and particulate organic carbon. The chlorophyll increase was due to the rapid growth of different diatom species. However, on the 24th day, all these increases stopped and began to linearly decrease. Mass death and rapid sinking of diatom aggregates caused the decline. Because algae uses carbon in photosynthesis, much of the carbon decline was due to that. The decline was also underestimated because the atmosphere reintroduces carbon dioxide. Additional carbon was also added because of respiratory losses in the algae. It can be concluded that the iron hypothesis is true. This is supported by three of the results. The increase in the chlorophyll shows there was an algae bloom. The large decline in carbon is because algae absorbed it, died, and sank to the ocean floor. There were low respiratory losses, so it can be said that CO2 was not reintroduced to the atmosphere. So what does this mean? As a result of this experiment, we can say that iron can be used to create large algae blooms. The algae will absorb carbon dioxide and is likely to sink to the ocean floor, where it will lay for centuries with sequestered carbon. So what can we do with this information? One major environmental problem today is the increase of carbon dioxide in the atmosphere caused by industrialization. This in turn leads to an increase in greenhouse effects, which is the main contributor to global warming. A possible solution to global warming could be carbon sequestration from algae blooms utilizing the iron hypothesis.